Previously, we studied 5 ways to prove triangles congruent. Those ways were side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. We also looked at 2 ways that didn't prove triangles congruent. They were side, side, angle, and angle, angle, angle. Today, I want to take a closer look at angle, angle, angle. In this example, triangle ABC and triangle MNO have some angles that are congruent. Angle A is congruent to angle N, and angle B is congruent to angle M. And I don't know how big angle C is, nor do I know how big angle O is, but I know that there's a total of 180 degrees in a triangle, so I can take 180 minus 25 minus 50 to figure out this missing angle. When I do that math, the missing angle is 105 degrees. So between these 2 triangles, I actually have 3 congruent angles. Even if I only know 2, I can figure out that third. Well, it turns out that angle, angle, angle doesn't prove triangles congruent. It actually proves triangles similar. If you think back to the example we did for angle, 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 those triangles were similar but not congruent. So I can make this truth statement. Angle ABC is similar to triangle. Well, just like with congruent triangles, I need to match up corresponding parts. Angle A lines up with N, and B lines up with M, and C lines up with O. So I need to make sure that my triangles are in the correct order. And the reason will be angle, angle. Notice I only need 2 angles. That third angle I can figure out, but I don't need. And I'm going to say angle, angle, similarity postulate, so it's not confused with any of my congruent theorems and postulates. Let's look at an example where we have to prove triangles congruent, or excuse me, triangles similar. We're given that segment AB is parallel to segment DE. Well, parallel lines give me congruent angles. So based on this given, I have some conclusions that I can make. Segment AB is connected to segment DE by transversal BD. When I trace out that transversal, I have 2 alternate interior angles that are congruent. Angle B will be congruent to angle D since my lines are parallel. I can also trace out transversal AE, and I can see that angle A and angle E are congruent because they're alternate interior angles between parallel lines. And if I look, the way that these 2 triangles are drawn, I also have vertical angles that are congruent. So if I'm going to prove these triangles similar, I'm going to use the angle-angle similarity postulate. When I write my proof, I need to make sure that I have 2 pairs of congruent angles congruent to conclude that my triangles are similar. So let's write this proof. My first statement is going to be my given. Segment AB is parallel to segment DE. Because my lines are parallel, I can conclude that I have alternate interior angles that are congruent. Because statement 1 is true, I can conclude that statement 2 is true. Angle B is congruent to angle D by the alternate interior angles theorem. That gives me my first pair of congruent angles for angle-angle similarity. Now at this point, I have a choice. I can go to angle A being congruent to angle E, or I can go to vertical angles. In this case, I'm going to go to vertical angles. Now if I want to name this angle right here, I can't call it just angle C. I can call angle B, and angle D, because there's only one angle around those vertexes. But if I'm going to name this angle, I have to name it with 3 letters. A, C, B is congruent to angle, and again I need 3 letters for this angle, D, C, E. And the reason that these 2 angles are congruent is because they're vertical angles, and by the vertical angles theorem, vertical angles are congruent. So now I have enough information to conclude that my triangles are similar. Triangle ABC is similar to triangle. Now look at the order. ABC, EDC. A has to correspond to E and B to D, and then C to C. EDC by the angle-angle similarity postulate. I could have used this angle, this pair of congruent angles, A and E, but I don't have to. I can just pick 2 and write my proof.